Good morning, my dear students. How are you doing? I hope you enjoy your vacation and my videos. Today our lesson is talking about integration by parts, and we started this topic in the previous videos. Quickly, we would like to repeat again the rule, which is the integral of u dv is equal to uv minus the integral of v du. And we said that to choose u in order of the word Leti, which is L stands for logs, and I stands for inverse, and the A stands for algebraic functions, and T stands for trig, and E stands for exponential function. Let's take more examples for integration by parts. The first example is find or evaluate the value of this integral e to the power of x cosine x. First of all, we will let u is equal to, what comes first, trigonometry or exponential? Yeah, in the word Leti we said that cosine will be the u because it's trigonometric function, and the derivative here du is equal to, yes, the derivative of cosine is negative sine x dx. Okay, then on the other hand, we will let dv is equal to e to the power of x and dx here. What's the integral of dv is v, and the integral here of e to the power of x is the same, e to the power of x. Okay, and then substitute in the formula, which is the integral of u dv is equal to uv minus the integral of v du. So my answer will be the integral of e to the power of x cosine x dx is equal to the u, which is cosine x, times the v, which is e to the power of x, minus the integral of v, which is e to the power of x du, and du is negative sine x dx. The next step, the integral of e to the power of x cosine x dx is equal to e to the power of x comes first, cosine x, negative is positive, the integral of e to the power of x sine x dx. Here is the problem that this part, again, the integral of e to the power of x sine x dx, we should follow the integration by parts again in this part. So for the second time, I will let u the trig function, which is sine x, and its derivative du is, yes, cosine x. Good. And then dv is equal to e to the power of x, and the integral for each side, to integrate each side, v is again ex. Okay, it's ex, and here's u for the second time. So the integral of e to the power of x cosine x dx is equal to e to the power of x cosine x plus, here will be uv minus the integral of v du, which is the u, which is sine x, times the v, which is e to the power of x, minus the integral of v du, the v, which is ex, and the du again is cosine x dx. I forgot here the dx. Nice. If we still doing by parts for many times, the question will not finish, but here the trick in this question is to only take this side to the other side with different sign and combine like terms. As you see here, negative the integral of e to the power of x cosine x dx, and in the left hand side we have the integral of e to the power of x cosine x dx, so we can combine these two terms together. And when you move one term from one side to the other side, you just change the sign, right? So it's 2 the integral of e to the power of x cosine x dx equal e to the power of x cosine x plus e to the power of x sine x. The final step is to divide each side by 2 to isolate your integral. Dividing this all by 2 is the same as multiplying by half, so it's a half e to the power of x cosine x plus 1/2 e to the power of x sine x, and that's it. So this is our first question in this lesson. The second example here, evaluate the integral of x squared root x minus 1. According to the word Latte, we have two algebraic functions in this case. So the first one is x squared and the second is root x squared. So we're gonna use here a new way, which is the way of table. What's the way of table here? I will make a table and divide it into two columns. The first column here for repeated differentiation, write R differentiation, and the second column for repeated what? Integration. So this way is called the way of tables. We make only one table and then we try to solve the question by using this table. Yes. It's called the tabular integration by parts. Step 1, differentiate the first part. What's the first part? E to the power of x squared. We will find the derivative of x squared until you obtain 0 and list the results in the first column. Okay? The second step is to integrate the second function, which is root x minus 1. Also, guys, repeatedly, and list the results in the second column here. And then we will draw arrows, okay, from each entry in the first column to the entry that is one row below or down the second column. Don't forget also to label the arrows with alternating positive and negative, starting with a positive. Let's start here. We said that the first part here is x squared. We put it here, x squared. And then we will find or skip finding the derivative of this part until we get 0. What's the derivative of x squared? Excellent, here you, which is 2x. Nice. What's the derivative again of 2x? It's 2. Excellent. What's the derivative of any constant? It's 0. Nice. The second column here, we will find the integral of the root x minus 1. Root x minus 1 can be written as x minus 1 and this all to the power of half. What's the integral here? We just drop that exponent and add 1. We will add 1 to the exponent and divide by the new exponent, which is 2 over 3 x minus 1, and add 1 to the half will be 3 over 2. But when you divide by 3 over 2, you will flip your fraction because the denominator of the denominator is numerator. And here, the second one will be the same, x minus 1, but we add 1 to 3 over 2, it's gonna be 5 over 2. And it will be here 4 over 15. Why? Because 2 over 3 times 2 over 5. Okay, for the last time to be equal for this row, x minus 2, we will find the integral by adding 1 to 5 over 2, which is 7 over 2, and then 4 over 15 times 2 over 7, okay, which is 8. 4 times 2 is 8, and 15 times 7 is 105. Then you should draw an arrow from each entry in the first column to the entry that is one row down in the second column, like this. Here, from x squared and from 2 squared to 4 over 15, from 2 to 8 over 105, and then you should here label the arrows with alternating positive and negative signs, starting with a positive, like this one. Positive, and then negative, and then positive. Finally, you will write your answer. How to write your answer? It's so easy now. The sign first, positive, and then 2 over 3 x squared, this here, okay, x minus 1 to the power of 3 over 2. Then the sign first I said, which is minus now, which is minus 2 times 4 over 15, which is 8 over 15, x minus 1, this all to the power of 5 over 2 plus the 2, you will multiply, it should be plus here because the last sign here with me above the arrow is positive. 2 times 8, which is 16 over 105, x minus 1 to the power of 7 over 2, and this plus c, and this is your answer. I know that all the students will enjoy by this way. Now in question 3, what if your question here is the integral of tan inverse x dx, and I'm gonna add here the definite integral. You know the definite integral. Let's do this question and find the value of this integral from what to what? From 0 to 1, the integral from 0 to 1 of tan inverse of x dx. In this example, I'm gonna illustrate how integration by parts can be used to integrate the inverse trigonometric functions. Pay attention, please. First of all, I'm gonna let here at the right the u. The u, according to the word late, is L-I-A-T-E. So I comes second after the logarithms. So u will be tan inverse of x. Okay, mister, what is dv? Yes, dv will be dx. No problem. 1 dx, the same. From the first part, I'm gonna find the du. What's the du? The derivative. What's the derivative of tan inverse of x? Which is 1 over 1 plus x squared, because it's tan. dx. Yes, this is a rule you should know before. dv is equal dx, and the integral here v is equal to, sure, x. The integral of dv is v. The integral of dx is x to the respect of x, the integration. So here let's substitute in the formula, which is u v minus the integral of v du. Now what's the u? The u is tan inverse of x, and v is x. So I'm gonna write first x tan inverse of x, which is u times v. This all will be, guys, don't forget, from 0 to 1, minus the integral of v, yes, v which is x, times du. Du is 1 over x squared plus 1, or 1 plus x squared, the same, and this to the respect of x. The first part is so easy, but the second part here, the first part I will leave it now, and then I will write it again, x tan inverse of x, and this should be, we should substitute from 0 to 1. We will do it at the end. But here, how to find the integral of this part? Yes, to find the integral of this part, I will multiply, all of you pay attention in this step, I will multiply by 2 and divide by 2. Okay, I will multiply by 2, it's gonna be 2x, I'll multiply up here by 2, and divide here by 2, or multiply the denominator by 2. The numerator will be the integral from 0 to 1 of 2x over x squared plus 1 dx. Why, mister? Because we have a formula, we have studied before, the integral of f prime of x over f of x is equal to ln absolute value of the function in the denominator plus c, right? Ln absolute value of f of x plus c. So it depends on this rule. I'm gonna multiply the numerator by 2 and the denominator by 2. Multiplying the numerator by 2, it will be 2x, and the denominator by 2, it will be here 1/2. I will let it as a constant. Yes, where is this 2? Yeah, this 2 went outside, behind the integral sign. My answer will be x tan inverse of x, and this all from 0 to 1. 1/2, what's the integral now? Will be ln absolute value of x squared plus 1, and this all should be also substituted from 0 to 1 as we learned in the definite integral. When you substitute 0, we will substitute first 1, so it will be 1 tan inverse of 1. Yes, what function, what trig function? Its tan is 1, I know. It's pi over 4, 45 degrees, right? Minus 1/2, then ln, substituting 0 for anything is still 0, tan inverse of 0 is 0. Okay, so here, this all for 0, we will not substitute. You know, it's 1/2 ln 1 plus 1, which is 2. Minus, it should be minus 1/2 ln 0, which is not here, not found, undefined. So here, what's the final answer? It's pi over 4 minus ln 2, right? Pi over 4 minus ln 2. Okay, this is my final answer. This is the final answer, which is pi over 4 minus ln 2. Okay, thank you guys. I hope you enjoy all questions, and I hope you understood everything.